Everyone. I, Vishali Upperwal, welcome you all to the TSDSI Tech Deep Dive Conference 2026. We are now moving into the hybrid tech session summary segment. Over the last few days, we have hosted six insightful technical sessions covering key theme shaping next decade of communications, 6G standards, systems, and cross-sector.
Participants from DOT, 160, Wipro, and Reliance Jio. There was one key element to our session was that 3GPP RAN 3 chair and 3GPP RAN 3 repertoire were part of our keynote lineup, where currently the key discussions on 6G architecture debates are happening. Next slide. So yeah, till we open the slides, we designed the session around 4 open questions that are currently driving the 6G architecture discussions. First one was that should 6G be an evolution or purpose-built architecture? Second, can networks be AI native, intent-driven, or compute-aware? Third, will service plane emerge alongside control plane and user plane? And the last but not the least, we also discussed how do we enable terrestrial and non-terrestrial convergence, ISAC integration, and the use cases. And I'm pleased to report that we got substantial responses on all the questions. Yeah, thank you. Regarding the 4 questions, the first on evolution versus purpose-built architecture, the keynotes converged unambiguously that 6G is shaping as the disciplined evolution, as suggested by, as highlighted by the 3GPP RAN 3 chair, that it's the framing is not towards evolutionary or revolutionary. Okay. Yeah, thank you. Oh yeah, it's better. The framing is not towards evolutionary or revolutionary, but innovate to enable new frontiers, but deliver and reuse whatever can be delivered right now. Importantly for our members, we brought out some key outcomes that some decisions are already logged. The 6G core will build upon evolved 5G core, and the CUDU split from 5G is retained in 6G. So a key message here is that baseline is being fixed right now. If we miss to introduce our features right now, it will be difficult to bring it out later. Second, on AI role on 6G is being organized into 3 categories: AI on RAN, AI for RAN, and AI and RAN. But there was one key message we heard repeatedly, which was 6G must support many different data types, sources, and usage models, and data itself becomes a system design challenge. Third, the genuinely open question around RAN core interaction model. 2 competing approaches, procedure-based and service-based approach is being discussed, which remains active under 3GPP RAN 3 study, and our members can contribute towards it, because the trade-offs across both the models alongside determinism, efficiency, extensibility, and flexibility remains under study. And fourth, and which we have been hearing today a lot, on terrestrial and non-terrestrial, perhaps we had the clearest shift of the session, that non-terrestrial networks are now treated as core infrastructure, not as the backup option anymore. The direction with GEO, LEO, and HAPS integrating with the ground networks as the one 3-dimensional system. And also we discussed about the tighter satellite ground handover, which was extended and which was supposed to be and discussed to be extended towards the 4G legacy devices. Docomo grounded this in lived experience with the satellite restored coverage after the Noto Peninsula earthquake. Next slide, please. The panel brought welcome candor, and the slide captures one-line takeaways from each voice. From DOT, Shri Ashok Kumarji confirmed the India 6G push is already underway with the funding schemes, with the support for MSME and startups for standardization activities, for IPR support with the 100 5G labs. All building India make should be in the service of that. Thank you.
Thank you, Sonali ma'am, for those valuable insights over emerging 6G architecture options. So as session 2 was on AI native 6G, now may I request Mr. Jesu Maria Anthony, as Data and AI Solution Architect in the CTO office at Tata Elxsi and co-chair for session 2, to present the session summary. Mr. Jesu is joining us online. And we are resuming this session for just 1 or 2 minutes. Thank you for cooperation.
Hi, thank you so much. Maybe we can move on to the next slide, please. Yeah. This is a short summary of what happened in the session 2. Session 2 had 2 parts, a set of keynotes, 20 minutes each, and we had a very detailed panel discussion. So this is summary of the 3 keynotes that happened on the topic of AI native 6G from academia and industry. The first session was on the topic called Towards AI-Driven RF Semantics by Professor Sundaram Vanka from IIT Hyderabad. The theme around which the topic went through was the AI understands the world. So the keynote from professor was challenges to rethink intelligence at most fundamental layer of the fundamental layer of your fundamental layer of the communication. The radio itself, it talked about the RF semantics. It moved us beyond the traditional spectrum sensing towards contextual understanding of the wireless environments. And it also kind of represented a powerful shift from the communicator system to the cognitive where AI comes in picture. The second keynote was given by Mr. Jnana Prakash Sebastian, which expanded discussion broader to network architecture. We heard how AI native 6G can be viewed through 3 complementary dimensions: AI embedded into networks, AI for networks, and network AI. The topic was around 6G coordinate networks, AI, agentic AI, DTA knowledge graphs. The vision actually represented was not merely about network automation. It is about transforming the telecom infrastructure into a distributed intelligence platform for industries and society. And this was around the theme of AI operates a network. The next theme was around the AI scales to standard. It was on the topic of earning AI native 6G. Our third keynote was given by Mr. Aditya Chaudhary, brought an equally important perspective: the need to earn AI native 6G through standards, interoperability, and deployment realities. He also reminded us that the future cannot be built in isolation from the networks we already operate. AI native 6G will only succeed when the intelligence can function across multiple vendor, multi-domain, federated environments. Most importantly, he highlighted that the standards in Windows open now. The choices we make today will shape the global 6G ecosystem for years to come. So all the keynotes, even though they are from different titles, they kind of together they gave us a very broader meaning around AI understands the world, AI operates a network, and AI would scale through standards actually. We can move on to the next slide. Another short summary of the keynote, then I'll go to the summary of the thing. So together, we from the keynote, we had AI understands the world, AI must operate the network, and AI must scale through standards and collaboration. Most important takeaway that we got from all the keynote speakers is that AI native 6G is not just about faster networks or smarter algorithms. It's about building a trusted intelligence infrastructure that can support future economies, industries, governments, and societies. The journey from the concurrent networks to cognitive networks is underway. The journey from automation to autonomy has begun because of AI. And the journey from communication infrastructure to making it to an intelligent infrastructure is now becoming reality, as per the insights given by our academia and industry partners. So I thank all the keynote speakers for that. And maybe we move on to the next slide. The second part of the session was moderated by Mr. Hemant Rath, where we had a panelist from Mr. Abhishek Thakur from IDRBT Hyderabad, Novena Govias from BITS Bilani KK Goa campus, Mr. S.S. Singh from KIT Bhubaneswar, Ms. Jyotsna Bapat from IIT Bangalore, and Winso Babu James from Qualcomm, and Mr. Amit Kumar from TEC. The key takeaways of the session were we had 2 rounds. The first round had the 4-minute speech, and the second was a follow-up question, where the key takeaway points from this were realizing AI native 6G will depend much on the standardization deployment as on technology innovation. And AI native 6G is not just another evolution of mobile networks. It is the intelligent infrastructure that will power the Industry 5.0, autonomous enterprises, smart societies, and sovereign AI ecosystems. Existing multi-vendor and multi-generation networks will coexist with 6G for years. And one of the key things that was also discussed on the making interoperability, open interfaces, and common architectural frameworks very essential. and need for India to contribute the requirement-led standards that reflect national priorities, support sovereign AI infrastructure, enable trusted data governance, and create commercially viable pathways for AI-driven telecom networks. And we also had discussion about several cross-domain use cases that will be emerged, which need to be deployed on top of 6G, where AI networks is a key requirement, where we should think AI as the native component rather than just including AI in the solutions actually. All this becomes reality only when the semiconductor industry comes up with on-chip solutions to ensure the energy, time, cost, and resource guarantee is there. The real transformation lies not only faster connectivity, but enable networks that can understand, learn, decide, and act autonomously while supporting the next wave of intelligent applications. So this is the key summary of the panel discussion. If you see both the keynote as well as the panel discussion kind of gelled in together, even if it was not planned, they gelled in together, and we had a wonderful contribution from all the panelists. I would like to take this opportunity to thank all the panelists who had volunteered and participated actively and gave their thoughts and created that common intelligence for us actually. Ma'am, we can go to the next slide, please. And this is my last slide. On behalf of the session organizers, I would like to express my sincere gratitude to our distinguished keynote speakers, panelists, moderators, the TSDC leadership, the session coordinators, and all the participants who contributed to this enriching discussion. Thank you. This is Jaysumari Anthony from Tata Elxsi, and also thanks from our Dr. Hemant Rath from TCS actually. Thank you, ma'am. Thank you all the members in person there. Thank you so much.
Thank you, Mr. Jesu, for that engaging and forward-looking outline for the session. Now, session 3 was on security, privacy, and trust in 6G. For that, I now invite Mr. Saurabh Khare, the chairman of the Security Working Group at TSDSI, and heads the Nokia 3GPP SA3 Security Delegation and co-chair of session 3, to present the key discussion points and challenges around security, privacy, and trust in 6G. So we would like to have you on the stage, please. Yeah.
Thank you. So let's move to this. This is session 3, security, privacy, and trust. So as you can see, we have a 3 keynote speaker. First keynote on end-to-end security for 6G and 3GPP status, which is from Mr. Rajvel. He's also a 3GPP SA3 chair. Second keynote is from developing security at international forum, including IETF, from Mr. Thiru from Nokia. Third keynote speaker is end-to-end security and national perspective, Mr. G. Nagendranath from NSCS. Then we have panel discussion. Panel discussion is led by Mr. Kurbakaran, our co-chair. And panelists were Anupam Agrawal from TCS, Ms. Saujanya from MNNIT, Mr. Manjesh Kumar Hanwal from IIT Bombay, and Mr. Subramanya from SETS. Can you move to the next slide, please? So we started our discussion talking about, considering I'm also a TSDSI Security Working Group Chair, we started as a discussion about what we are doing in TSDSI security. And I'm feeling immense pleasure to say that whatever security work we are doing from last 2-3 years for 6G, it's being anchored in different global forums. So right-hand side, what you see, the global forum 3GPP SA3, which is in yellow color, middle color is IETF, which is in white color, sorry, IETF PQC agentic stuff, which is in white color, and the blue color is ITSI ISG, QKD, and SG17 group. And you can see left-hand side, whatever security working group or security studies we are running from last 2-3 years in our TSDSI. And we put them in our color code so that we understand, hey, PQC studies, what we have done 2 years back now is being anchored in 3GPP and IETF. The agentic stuff, whatever we have explored, it's also being discussed in different forums. So that's a big achievement from India side, where whatever work we have been exploring as a part of security working group in TSDSI, that has been anchored in global forums. Can you go to the next slide, please? So next is the 3 keynote speakers. So we choose the keynotes based on different forum, because TSDSI is creating a research and standards. Now, first keynote is on the 3GPP security and the role in 6G. So first keynote speaker summarize what 3GPP is doing in terms of security. So they talk about end-to-end security architecture, PQC and AED cryptography. So cryptographic enhancement, definitely PQC is a main thing what we are doing in 6G, and that will include 5G as well. Then 3GP is also working on RAN security, UE to core security, core network, infrastructure, and roaming security. Then the agentic. This agentic stuff is a new in 6G, so it will take some time, but work on security has been started, and data framework security. Last but not the least, the sensing work, which has already started in 5G, is continuing in the 6G as well. So we had a detailed discussion, what 3GP plans, how they're planning to do, what all things they are going to cover. Second keynote speaker mainly focused on IETF security. So IETF mainly working on internet security protocols, right? But they mainly work on the TLS, IPsec, EAP, OAuth. These are the protocols which are relevant for 6G. Then we have cryptographic enhancement, cryptographic agility, and PQC readiness. So they defined the RFCs which are being integrated into 3GPP and different groups, right? They have already enhanced our TLS RFC, IPsec RFCs to make crypto align with the PQC, and these transport layer protocol are fully start supporting the PQC. Then recently work has been started on trust framework for agentic AI. And at the last, like TSDSI is doing a research which will be used in 3GPP and IETF. So the point is, these standard, if TSDSI, 3GPP, IETF, they are not competing with each other. They are complementing each other. So whatever work is being done, suppose take example of IETF, they're finding the protocol, those protocol is being used in 3GPP. Whatever work we have done as a pre-standardization research in TSDSI for security, that work is being anchored in 3GPP now. Last keynote is on the national security mainly. So we talk about end-to-end security and different national security perspective. So we started saying that telecom is becoming like a critical infrastructure. So we have to take security on top priority now. So we discussed the issues or progress on the security by design expectations. So security by design, the network layer or the hardware layer or architecture layer, every layer we have to introduce security by design. Then we talk about supply chain security, transparency, SBOM, CBOM, crypto agility, regulatory and lawful enforcement needs. Lawful enforcement typically currently being used in Europe and US market, but also we need to explore more in the Indian market. Can you go to the next slide, please? Yeah. And this is a panel discussion summary. So this is led by Mr. Korbakar, our co-chair. So 3 key points came out as a part of a panel discussion. First point was security by design as a core 6G principle. So security, privacy, trust, resiliency must be embedded into 6G architecture from day one. Now 6G design has been started in different standards forum. We need to ensure security is integrated. It should not be afterthought. That we have to ensure. Otherwise, it will be a big cost for all of us. Second more prominent point which came out is AI native 6G. So new AI, we all talk about, in previous sessions also talk about AI. So AI is coming as a new opportunity, but it's coming with a new risk. Those risks we have to take care. AI native network introduce emerging threats such as adversarial attack, model poisoning, autonomous cyber threats. So both, we have to work on AI for security and security for AI. Both will be a critical research and standardization perspective we need to explore. Third, but not the least, this preparing for quantum era. Future network must be quantum resilient. So PQC, QKD, hybrid cryptography approach to ensure long-term perspective. So that was a summary of the panel discussion. And the last, together, we have opportunity to make 6G not only faster and smarter, but also more secure and resilient than any previous generations. With that, I would like to close the session. Thank you.
Thank you, sir, for outlining the roadmap and challenges ahead in security and privacy in 6G. Now, session 4 was on HAPS-based connectivity, technical feasibility, trials, and market dynamics. For the summary of session 4, I now invite Mr. Abhijit Abhimanyu Masal, Principal Research Engineer at the CIVIT, Chennai, Chair of TSDSI Study Group Networks, and co-chair of the session. To share key highlights and recommendations, Mr. Abhijit is joining us online.
Thank you, Vaishali, and good afternoon all. So as a co-chair, I will be presenting the summary of session 4. We can go to the next slide. So the session 4 was mainly the talk was on the HAPS. There were as the other sessions, there were three keynote talks and followed by the panel discussion. In the panel discussion, there was a short talk on the waveforms for the HAPS. So the session was joined by distinguished voices from industry, research institutes, and the telecom operators. So we can go to the next slide where I have presented the summary of the keynotes. So the keynotes was by three distinguished speakers. First was Dr. Sakata from SoftBank. As we know, SoftBank is the pioneer in the HAPS related activities. So Dr. Sakata has brought out very key points about the HAPS, where the HAPS has become a very important complementary network layer for the terrestrial and satellite communication. Also, he has brought out the different platforms that are being used for commercial trials from the SoftBank point of view, which are called as HTA and LTA. It was been highlighted that as mobile communication has become a very essential commodity, having a 3D networks is an important aspect, and having HAPS will be very essential for a certain services. He also brought out the commercial adaptation roadmap of SoftBank in Japan, and he highlighted that emergency use case is one of the important for the HAPS. Followed by the talk from the academia, Dr. Animesh, who brought out very forward-thinking thought on the HAPS, where what are the new services and the technology can be utilized for the HAPS, the feasibility of various new scenarios like RIS, ITS, localization, ISAC was being talked in his talk. Then it was followed by Prafulla Kumar from Jio, where he has brought out the roadmap or kind of activity that Jio is looking towards and HAPS, and brought out the different aspects with respect to the regulatory criteria that we have around the HAPS related platforms. Also, he brought out a very key important aspect that we have to make the economics right around the HAPS for HAPS to become a very commercially viable solution going ahead. He also proposed a very forward-thinking thought that India should have one kind of test bed to see the activities on around the HAPS. It was followed by, so these were three keynote talks, which was followed by a panel discussion. In the panel discussion, we had a short talk from Professor Timothy from University of Sheffield, UK, where he had proposed, put down his ideas towards the waveforms about the NTN and the HAPS. So this was the summary from the keynotes. Then we can look for, we can go for the panel discussion summary. After the keynotes, we had a panel discussion. Can we go to the next slide, please? Yeah, so panel discussion was with again the speakers from the keynote, plus the Professor Timothy has joined us. The main this particular session was moderated by Suresh Kumar from Susan Future Technology. So the main the idea where the panel discussion was spanned was how what is the need to solve before HAPS become a trial to a routine deployment. So many interesting ideas and thought-provoking discussion came out, in which which I have summarized into three different columns, where the important aspect was the endurance of the whole network with HAPS, and the power consumption was brought out as one of the important pillar, followed by the different regulatory aspects and the interference to the different terrestrial networks also has a very important aspects that was being discussed, as HAPS being in a overlapping footprint with the terrestrial networks. And it was equivocally discussed that coordinating the coordinating HAPS satellite and terrestrial layers together is an important aspect for future networks, and HAPS will play a very key role for technologies which are intermediate, which are which serves a very critical services which may not be served by a terrestrial as well as a satellite system. So it will be a complementary system which will work together. So that was the key thought that has been brought out from the panel discussion. So with that, I would like to conclude my summary session. Thank you very much for the effort from the organization, and thank you and it was a very thought-provoking session from in a session 4 on the HAPS. So with that, thank you very much. That's it from my end. Thank you.
Thank you, Abhijit sir, for spotlighting the HAPS-based connectivity. Now, session 5 was on priority verticals and transformative use cases in 6G. May I now request Ms. Rupa, co-chair of session 5, senior telecommunications engineer and researcher at the Center for Development of Telematics, CDOT, to present the key insights from her session. Ms. Rupa is joining us online.
Good afternoon. The session 5 was on priority verticals and transformative use cases in 6G, and it had 3 keynotes followed by a panel discussion. Shri Anil Bharadwaj, DDG SC DOT, presented based on BharatNet 6G vision, the government focus on 6G, initiatives of testbeds, cooperation of Bharat 6G with other countries, priority verticals, contributions to standardization process, and readiness of infra and spectrum for 6G by 2028. Keynote 2 from Mahindra AI put forth some specific use cases and industry expectations from 6G capabilities and extending 6G services as consumables via APIs. And okay. Keynote 3 by Shri Arvind Pandey, TCTS, was on digital twin, data governance, privacy, security, agentic AI, and sovereign AI for vertical ecosystems. From networks to platforms, a unified 6G service delivery architecture for vertical ecosystem. These were the keynotes conducted. And then the panel discussion consisted of Shri Devendra Singh from TEC, Ms. Aditi from Intel, Shri Manoj Khanna from Invas, Dr. S.K. Mishra from Kalinga Institute of Medical Sciences, and Ms. Praksha from startup sector. It was on priority use cases, enablers, and challenges. So the key takes from the session are healthcare and agriculture emerged as the highest priority national use cases, highlighting the potential of 6G-enabled AI to address India's critical socio-economic challenges. Ubiquitous connectivity along with explainable and trustworthy AI was identified as a foundational requirement for enabling scalable and reliable AI-driven 6G applications. Given India's diverse geography and demographics, there is a need for a standardized open platform that abstracts the complexity of underlying 6G technologies while enabling seamless integration across industries and end-user ecosystems. A national reference model for 6G use cases was recommended to provide a common framework that the ecosystem can adopt for developing, evaluating, and scaling innovative applications. Ma'am, next slide, please. Future 6G use cases should prioritize inclusivity and affordability, ensuring that the benefits of advanced connectivity and AI are accessible across all segments of society. Success of 6G use cases should be measured through sector-specific outcomes with a clear mapping between business domain KPIs and the corresponding 3GPP network KPIs required to achieve them. Bridging this gap is essential for meaningful deployments. Manufacturing as a case study was discussed. A stronger startup ecosystem is critical to accelerate innovation, supported by 6G laboratories, national level, simplified access to grants, industry collaboration, and testbed infrastructure to enable rapid prototyping and commercialization. These were the key takeaways of session 5. With this, session 5 summary is concluded. Thank you.
Hello, good afternoon.
Thank you, Rupa ma'am, for the valuable insights over transformative use cases in 6G. Now, session 6 was on open and interoperable systems for seamless connectivity of heterogeneous networks. And finally, I now invite Abhijit Chaudhary, founder and CEO of Neural Networks, specializing in private 5G, edge computing, and AI-powered networking solutions, to share the key takeaways from session 6. Mr. Abhijit is joining us online.
Yeah, good afternoon, everyone. It was a really insightful session yesterday, where we had delegates from GSMA, Fiverr, Nokia, NVIDIA, Keysight, Geo, as well as, of course, from Neural Networks. So it was co-chaired by me and Mr. Mahesh from Geo. Can you please go to the next slide? And the keynote speakers had Devashish from GSMA, Mr. Devashish, then Mr. Chandra from Fiverr, Mr. Ashish from Nokia, Charles from NVIDIA, and Prasad from Keysight Technologies. So please go to the next slide. Yeah, I think this is the key takeaways. So what we discussed in the first keynote was about GSM's open gateway and it being a standard for network APIs. I mean, the GSMA open gateway is an API platform through which any application developers can actually access advanced mobile network functions without needing to integrate separately with each operator. So it's a common API for any application developers can use to connect to any of the telecom infra of the operators, and GSMA is making it open to build value-added applications on top of that, and you can get information like device location, number verification, SIMs web, billing, etc. Of course, there will be some secured APIs to be taken care of, but this has helped. Like one of the use cases was how it actually helped in Sri Lanka the carrier to actually ensure that the spamming and scamming is reduced there. So using those, it was a good use case we just covered. Another option on the can you go to the previous one? Yeah, the other discussion that we had was on NGSI and MCP as a standard, open standard, how you kind of represent an entity or device in 6G, like a sensor, drone, AI, a machine, right? Like you need it to have some context for each of them, and you need to actually interact with the AI model to actually work and kind of adapt. So for that, NGSI, LD as well as MCP can be a good open standard based platform to represent and also for interaction with AI models. The third part was the agentic network for multi-domain intelligence. It was covered by Ashish from Nokia, and it was about how the telecom network or the heterogeneous network, which has telecom and satellite, is getting disrupted, and managing both terrestrial and non-terrestrial we manually will not scale. You need to change and make it more autonomous, and that's where agentic networks will play an important role. Multiple autonomous AI agents for specific functions like radio, transport, core, NTN has to work and collaborate between each other through open standards and open APIs to enable intent-driven networking, closed-loop automation, self-healing, and basically making the service assurance autonomous. So that's what we talked about. Can you please go to the next slide? Yeah. The fourth keynote was from NVIDIA, and there they actually also emphasized that it's not only about open APIs. To enable open collaboration and basically to truly define open innovation, open source can play an important role for AI innovation, especially basically agentic AI can actually discover, evaluate new RAN algorithms, generate optimized code on their own. Manually, you need not code. Like code generated using AI, tested using AI, and then benchmarked using AI, and then continuously improving its performance. Everything through AI, and for that you need to at least open up some part of the code, which becomes important. That was one emphasis that they talked about. And as part of the panel discussion, the key technical challenges were discussed for heterogeneous 5G network. I mean, we are talking about 6G, cellular, Wi-Fi, satellite, NTN coming together, right? But there are a lot of technical challenges to be taken care of to deliver deterministic and mission critical services. One of them is the unified orchestration across multi-access technologies, Wi-Fi, cellular, NTN. Then common authentication and identity framework for devices to work across heterogeneous networks, like your mobile in Wi-Fi or 5G or satellite should be able to authenticate using a single mechanism, and then you should be able to move across heterogeneous medium seamlessly, so that continuous inter-technology handovers, inter-domain handovers have to happen. And lot of that has to be driven through AI. AI has to predict when a handover is needed and proactively do it based on the environmental and the demographic conditions. I also need to ensure end-to-end policy and quality of services. So cross-domain observability and service assurance becomes important too. So yeah, can you go to the last slide, please? Next slide. Yes, thanks. So the last part was when you talk about pilots, national pilot across heterogeneous systems. So we had a discussion what can be done fast and we can start with. So what you have seen is that in a national level or at an international level, some of the international pilots have already started for interoperability trials between 5 cellular as well as NTN network. Plugfest are being also conducted. But from an Indian perspective, I think the discussion revolved that one important part is about railways, where we can try that. Already there are work going on 5G for railways, but can it be made? Can it be extended to NTN network, ensuring that uninterrupted connectivity, ensuring the anti-collision system of the railways are supported both by cellular as well as satellite network, supporting each other. Second is disaster management. Whenever the terrestrial network goes down or gets damaged, you can use the satellite network during emergencies. Defense would be a big user, I think, and globally too, for 6G as well as cellular as well as terrestrial, non-terrestrial networks. And lastly, for the demographics in India, rural also can play an important role for extending broadband services, not only to cellular but in pockets through non-terrestrial satellite network. So this was, I mean, the key takeaways of the session, and I think we'll look forward how things can be implemented based on the takeaways in the Bharat 6G or in other organizations that we, TSDSI, etc. together. Thank you. So that is what I think we have to cover as part of.
Thank you, Mr. Abhijit, sir, for those valuable inputs and concluding reflections. Thank you to all the speakers for presenting and such crisp and meaningful recap of each session. The discussions across all 6 sessions have offered deep technical perspectives and clear directions for future standardization and innovation efforts. We now conclude the hybrid tech session summary. Please don't forget to share your feedback using the link which is given in the PPT here. Thank you once again for your participation. Now, I am delighted to announce that our Honorable Minister of Communication, Mr. Jyotiraditya Shinde, will be joining the valedictory session, which will begin on 3:45 p.m. Sharp. I request all the guests present here to remain seated. Online participants are requested to join the valedictory session on the AirMeet tool, and the session will go live at 3:45 p.m. Thank you, everyone.